If you're planning to get a new kidney from black market, remember to grab this drug before you go.
Hello, everyone. This is our Chem 160 presentation. My name is Daniel.
And my name is Peifeng, and we are presenting the total synthesis of cyclosporine from Danishevsky group from the University of Columbia. Cyclosporine is an immunosuppressive agent. When a patient receives any transplanted organ, such as the kidney, right? His immune system is gonna treat the organ as an alien because that organ is not part of his body. So the T cells in the immune system will respond and give the patient some side effects such as allergic reactions. So cyclosporine will be used to suppress the response. Here's the retrosynthetic plan of cyclosporine provided by this group. So they break the cyclic peptide into 3 fragments. Fragment 2 is a commercially available amino acid residue, but I think you probably couldn't get it from the black market where you get your kidney from. So probably buy it on Sigma Aldrich. And fragments 3 and fragment 4 are 2 peptides where you can synthesize them from single amino acid coupling. The synthesis of fragment 3 and fragment 4 will be discussed later.
We are starting our forward synthesis. We will be working towards fragment 3 first. In this paper, the group is leveraging the fact that isonitrile mediated bond can be used to synthesize tertiary amide. Unlike the conventional carboxylic acid and amine to form amide, the author copied leucine acid, which is compound 5, and valine isonitrile, which is compound 6, together, followed by radical reduction using AIBN and tributyltin hydride to generate the N-methylamide. The detailed mechanism will be discussed later. After forming compound 7, TFA in methanol is used to remove the Bach protecting group. Then a retroazadeosolder methylation will be used to form the N-methylated compound 8. Similar approach using isonitrile to make tertiary amide is used to generate compound 11. Then palladium carbon is used to deprotect the benzyl group. This leads to the coupling of compound 11 and compound 8 to generate fragment 3. This amide coupling used DPBT as the coupling reagent, DP as the base. Both of the mechanisms will be talked about later. Then we are on to the synthesis of fragment 4. Microwave radiation of azido acid compound 12 and isoleucine isonitrile compound 13 to afford informal amide compound 14, followed by an amide coupling to generate compound 15, then a lithium borohydride reduction and a methylation to generate compound 16. Selective reduction of the azide with triphenylphosphine in the presence of water was used to form compound 17. Then another amide coupling and deprotection was done to generate compound 18, which has 1 tertiary amide bond and 2 secondary amide bonds. We are now well positioned to test additional isonitrile-mediated amide bond formation. So, cyclic acid compound 19 and the amine compound 20 are coupled to produce dipeptide compound 21. Then a benzyl deprotection was done to form compound 22. Lawson's reagent was used to turn carboxylic acid into cyclic acid compound 23. After that, they were coupled with secondary amine to the compound 18 to generate fragment 4. Then a cleavage of the Bach protecting group was done. Now we're on to the coupling of fragments. Fragment 2 and fragment 4 are coupled together using DCC and HOBT, followed by HCl to generate compound 25. For the final 2 steps, first a benzyl deprotection of fragment 3 was done, followed by the coupling of compound 25 to generate the N-decoupled peptide compound 26, which is a 11 peptide chain. Then a hydrolysis of compound 26 was done using an AOH to reveal the C terminus, as well as a Bach deprotection to reveal the N terminus. The same isonitrile method also applies for cyclization. HOBT and microwave radiation in 70 degrees Celsius was used to generate our final product, cyclosporine.
Let's talk about our proposed mechanism of an important step in this whole synthetic route, the reaction between the cyclic acid and the isonitrile group. The thiol acid is an acid that's about 8 times stronger than the acetic acid. So the hydrogen can be deprotonated by the lone pair on the isonitrile group. Then the conjugate base of the thiol acid will act as a nucleophile to attack the nitrile. And after this step, we're going to perform an intramolecular carbonyl attack to form a 4-member ring. In the next step, the 4-member ring will rearrange to form this sulfur-containing intermediate. And lastly, we're going to use this reagent to do an radical reduction to form this fragment that will be used to synthesize fragment 3 that's mentioned in the previous slide. Next, we'll be talking about the mechanism of O-benzyl group deprotection. We're going to use hydrogen gas, palladium, and methanol in this reaction. The first step is the oxidative addition. We're going to insert the palladium onto the carbon. So the second step is a coordination where we put the hydrogen on the reagent. The third step is a hydrogen transfer, so that we can get rid of the alcohol. So at this point, we have successfully removed the OPN group. And the last step is the reductive elimination to regenerate the palladium.
For the last mechanism, we will talk about amide coupling. Amide coupling is a common theme in total synthesis. Since the C-terminus, the carboxylic acid end of the peptide, is not very active, we normally need a coupling reagent to promote the reaction. Here, the coupling reagent is DPBT. Now, back to the mechanism. First, the deprotonated oxygen will attack the electrophilic PO bond to generate a phosphorus 5 intermediate. Then, with the presence of the phosphorus, the lone pair of the oxygen will attack the carbonyl carbon to generate a more stable PO double bond. This activated carbonyl then is electrophilic enough for amines to attack. After the attack, it will generate a new tetrahedral intermediate. Finally, the lone pair on the negative charged oxygen will come down and kick off the leaving group and form the desired amide. Now, with all of the knowledge learned about cyclosporine, we will now know what to do in a black market.
Lastly, this is our reference. This is the end of our presentation.
Thanks for watching.